All right, class, this is number 11 and number 13. I do these a little bit differently than the book, so you can have a choice on how you want to do these. This is how I was taught to do these. Set up your Z going up, your Y going to the right, and your X is coming out at an angle on paper. It's actually coming straight out of my computer. If you do this on paper, it would be coming straight off of the paper. So that's how you can show 3 dimensions on a 2-dimensional plane. The book does it slightly different. They have the X and Y both kind of coming out of the paper at an angle, and then the Z still going up. Okay, it's personal preference. I just see this a little better because this is how I was taught in my engineering courses when we were plotting 3-dimensional points and vectors and different things like that. So here you go. We'll do number 11. We got A is 2, 1, 3. So in the X direction, we go 2 spots. So I'm going to count out from the origin. 1, 2. That's how far we're going in the X direction. So we're on this. We've come out of the paper or computer, in my case, 2 spots. So we're on this plane somewhere. Okay. The next thing we're going to move is 1 in the Y direction. So this is X, Y, Z. So 2 out to here, 1 in the Y direction. You can imagine all of these line segments coming down at, say, angles like this. From this spot down at angles. Okay. All right, sorry, my phone rang. Okay, this one's coming at angles, so I'm going to get rid of those lines. So if I move 2 in the X, 1, 2, 1 in the Y, it puts me right here. Okay, and now I want to move 3 up. So from here, I'm going to go up 1, 2, 3. Now I'm just measuring off. I'm going about these distances here. So 1, 2 in the X brings me to here. Okay, then 1 in the Y brings me to about here. And then you go straight up 2, 3, about the same as the distance in the background. Kind of confusing. It looks like it could be in a couple different spots. But this is 2X, 1Y, and then 3 straight up. Because if I started at the origin and went 3 straight up, 1, 2, 3, it'd bring me up a total of this distance. Okay, so I'm just going this distance up from this point, which is at 2, 1, and then 3 up. So here's where point A is for number 11. A little confusing. We'll try another one. How about point B? Get rid of all these lines. That didn't work. All right. Okay, so B is 1, -1, -2. So 1 in the X, but now I'm going to go -1 in the Y, brings me to here. So 1 in the X, -1, and then down 2. So 1, 2, about right here. Okay. And these don't have to be perfect. These are just your references. This would be 1, -1, -2. You won't have to do this on the test per se. There is going to be one problem where you're going to want to know, when we get to some of these problems later, you're going to want to know about where they are, though. It don't have to be, it's just going to be you graphing them, put them about where they should be. Let's do number 13, maybe that one we'll figure out. So 3 in the X, -1 in the Y. So 1, 2, 3, -1 in the Y puts it right here. Here's where A is for number 13. B, -4 in the X, so this is positive X. -4 would be back here along the same line, so about 1, 2, 3, 4. So I'm just guessing about where 4 marks would be out to here. 4 marks back would be about the same distance. So -4, 2 in the y. So from here, I'm going to go 2 marks to the right, because y is to the right, and then 2 marks up from there. It's a little easier to see this one. So here is point B for number 13. 4 in the -x along this axis, 2 in the y direction. This is about 2 marks, and then 2 up from our last point. So this is B for number 13. Hope this helps. A little bit confusing. Again, it's not an exact science. You're only going to be as good as your medium. If I had good graph paper here, it would probably look a little better. But again, I'm not requiring you to make it look perfect. Just try to get about where they are. So, all right.